Prehistoric Nature, where we give you the facts and info on prehistoric animals. Now, today I'll be diving into the giant ground sloth. Just imagine a larger version of your tree dwelling, veggie munching king sloth. What's on the agenda for today? We'll begin with an introduction to the ground sloths, major species of giant ground sloths, habitat and lifestyle, fossil discoveries, and scientific insight. And then with extinction and legacies. Right. In this section, which is the introduction to ground sloths, we'll begin with a definition and classification of ground sloths and end with the distinguishing factors of ground sloths from modern tree sloths. Now, ground sloths are part of the suborder Folivora and the order Pelosa and are part of the superorder the Xenarthra, which also includes anteaters and modern tree sloths. Unlike their arboreal relatives, these prehistoric creatures were primarily terrestrial and existed from the Oligocene through to the Holocene epoch, roughly 35 to million years to 11,000 years ago. Classified into various families such as Megatheridae and Mylodontidae, giant ground sloths show remarkable diversity in size and morphology and ecological adaptations across the Americas. Modern tree sloths are small, slow-moving arboreal mammals adapted for life in the canopies, with specialized claws for hanging and herbivorous diets dominated by leaves. In contrast, giant ground sloths were massive, ranging from several hundred kilograms to multiple tons, and adapted to a terrestrial existence with powerful limbs for digging and browsing. Differences also extended to skeletal structure and tooth morphology, with ground sloths exhibiting robust bones suited for weight bearing and diverse feeding strategies, unlike their modern counterparts. In this section, we will explore Megatherium and Erythmatherium, the South American giant, and other notable genres, as well as physical adaptations in major species of ground sloth. Megatherium was the largest ground sloth genre. No. Native primarily to South America during the Pleistocene, species like Megatherium americanum could reach lengths of up to 6 meters and weigh 4 tons. This giant was a slow-moving herbivorous browser, believed to stand on hind legs to reach high vegetation. Fossil evidence from Argentina and Brazil provide extensive information about its skeletal structure and habitat preference, illustrating its dominance in prehistoric ecosystems. Megatherium, another giant ground sloth genus, inhabited North and South America and was known for its exceptional size and long claws relative to contemporary breweries. Other notable genres included Mylodon and Paramylodon, which exhibited different adaptations such as armoring and digging capabilities. These genres occupied a range of environments and played diverse ecological roles, from grazing to browsing, reflecting evolutionary experimentation with ground sloths during the late Cenozoic. Giant ground sloths had thick, robust bones, large claws for defense and foraging, and dense a dense coat of inner fur from related modern species and fossilized hair. Adaptations included massive muscular bills for digging and standing upright, specialized teeth for processing tough vegetation, and in some species, defensive dermal ossification. These physical traits suggest a lifestyle adapted for both feeding on spectrum plants and protection from predators, reflecting their role as herbivores, megaherbivores. In this section, we'll explore their habitat and lifestyle, beginning with geographic range and environmental preferences, then dive into their feeding behavior and diet, and end off with social structure and reproduction. Giant ground sloths were primarily distributed across the Americas, from Argentina to the southern United States. Diverse environments such as tropical forests, grasslands, and savanna, no, Their environment preferences varied by species, with some favoring dense woodland while others thrived in open habitat. Climatic geographical changes during the Pleistocene influenced their dispersal and habitat shifts, with adaptations evident to fluctuating temperatures and vegetation types. Their fossilized stomach contents, tooth wear patterns, and isotopic analysis shows that giant ground sloths were herbivorous browsers and grazers, feeding on leaves, fruits, and possibly bark. Feeding strategies varied among species, with some adapted to high browsing and others to ground level foraging. Their slow metabolism, inferred from bone histology and modern relatives, suggest efficient digestion of fibrous plants. These feeding behaviors impacted vegetation patterns and contributed to shaping the prehistoric ecosystem. Though direct evidence is scarce, comparison with modern sloths and contemporary megafauna suggest that the giant sloths were solitary or lived in small family groups. Reproductive rates were likely low, with extended juvenile periods and few offspring, characteristics of large mammals with substantial genetic demands. Nesting and parental care behavior remain largely speculative, but infer from related species and fossil site associations. Fossil discoveries and scientific insight. Right. In this section, we will explore the scientific fossil sites and findings and end off with their methods of studying prehistoric ground sloths. Some key fossil sites include Pampas region of Argentina, caves in Brazil, and tar pits in North America, all providing invaluable specimens that inform on anatomy, environment, and extinction chronology. Discoveries range from nearly complete skeletons, allowing detailed anatomical study to trace fossils such as footprints, revealing behavior, radiocarbon dating, and stratigraphic context frame these findings within the Pleistocene epoch, while new technology allows for reinterpretation and deeper understanding of these ancient species. So, research employs multidisciplinary approaches, yes, including paleontology, radiocarbon dating, comparative anatomy, and isotopic analysis to reconstruct lifestyles and ecological roles. Advances in CT scanning, 3D modeling, and ancient DNA extraction have revisualized, revolutionized understanding of morphology, phylogeny, and evolutionary relationships. Archaeology and biology clarify the overplay between sloths, environment, and early humans. Theories behind extinction of the giant ground sloth, impact on ecosystem and interaction with humans, and lastly, the significance in modern research. That's extinction and legacy. Okay. Extinction theories include climate change and end of the Pliocene, reducing suitable habitat for food and resources, and overhunting by expanding human population. The overkill hypothesis likely a synergistic effect of environmental changes and anthropogenic research led to the decline about 10,000 years ago. Evidence includes changes in pollen and charcoal records, showing habitat shift, and archaeological sites indicating human interaction. Giant ground sloths played a critical role as megafauna, shaping vegetation and soil through feeding and movement. Their extinction likely triggered a cascading ecological shift, altering plant communities and other fauna distribution. Archaeological findings demonstrate their presence in indigenous mythology and use as food or tools, illustrating in complex human megafauna interactions that influence cultural development and ecosystem dynamics. Ground sloths have featured in indigenous myths and rock art across the Americas, representing formidable creatures in oral traditions. Contemporary research contributes to uncovering new fossil sites and applying novel technologies, deepening the understanding of their biology and extinction. Public interest foster conversation awareness for relatives and highlights the importance of paleontological heritage in understanding ecology, ecosystems, resilience, and evolutionary history. This presentation explored the fascinating world of the giant prehistoric ground sloth, covering their classification, major species like Megatherium, habitat and lifestyle. We delved into fossil discoveries that shed light on their existence and discussed theories behind their extinction. And understanding these ancient titans enriches our knowledge of prehistoric ecosystems and highlights their cultural scientific significance today. Unfortunately, we have come to the end of this episode. Stay tuned for more. If you haven't smashed that subscribe button, please do so. Every subscriber counts. And you can find me on Spotify, Instagram, and TikTok, as well as my other YouTube channels, the Animal Veggie channel and the Animal Online Guide, as well as Spotify under the Animal Adventure Podcast. So, without further ado, stay adventuring.